All right, let's go over the curve analysis outline. When you're doing these problems, sometimes it's helpful to just draw a quick sketch of what you're trying to think about, whether that's a maximum or a minimum or increasing, decreasing. If you draw a sketch, then you can kind of figure out, what the first or the second derivative tells you. So f of x is increasing. Okay, so that just means our slope is positive. If our slope is positive, then f prime, the slope function, is also positive. Likewise, if you are decreasing, your slope is negative. So f prime, the slope function, is negative. If f is concave up, so f double prime tells you the concavity. So concave up means f double prime is positive. If f of x is concave down, that means f double prime is negative. F has a relative maximum, okay? All right, so there are two instances I can kind of think of where I have a relative maximum, and that is kind of like a negative absolute value or a negative parabola. So a maximum occurs, your slope would equal 0, or like in the case of an absolute value, your slope is not 0, it's undefined. But really what's important here is not the 0 undefined part. What's important is this part, the change for f prime. So the slope changes from a positive to a negative slope. In both cases, we go from a positive to a negative slope. So our f prime changes from positive to negative. So notice that when we're saying there's a relative max, we don't just say f prime is 0 or undefined and then stop. In fact, this part is not really that important. This part is the important part. Changes from positive to negative. If f has a relative minimum, so likewise, you can have a minimum where your slope is 0 or your slope is undefined. And changes from a negative slope to a positive slope. So again, this is the important part. F prime changes from negative to positive for a minimum. So for a minimum or a maximum, you have to have the change. If you just have the first part of this, that f prime is 0 undefined, you will not get credit. There has to be a change for f prime. So again, f prime means slope. The slope has to change from negative to positive for a minimum or positive to negative for a maximum. All right, if f has a point of inflection, that means f double prime is 0 or undefined. So point of inflection, f double prime is 0 or undefined. So for example, you could have a concavity change like this, where your f double prime is 0. Or if you had something like this, where your f double prime is undefined because f prime is undefined, that's also possible. So f has a point of inflection. Really, what it matters here is that your concavity changes. So that's what a point of inflection is. It's a change in concavity. So if f double prime changes from positive to negative or negative to positive, so f double prime changes from positive to negative or negative to positive. Either way, we have a point of inflection. So f double prime changes signs, basically. If f double prime changes signs, then f has a point of inflection. All right, if f prime is increasing, okay, so f prime is increasing. So if I have an f prime graph, that means the slope of f prime is positive. Okay, well, f double prime is the slope of f prime. So if f prime is increasing, then f double prime is positive. And if f double prime is positive, we know f is concave up. So this is like a kind of question you can expect to see on an assessment. I was trying to make that a clearer A. Okay, like if I say f prime is increasing, what does that mean about f? So you kind of go through this process. If f prime is increasing, that means the slope of f prime is positive. The slope of f prime is f double prime. If f double prime is positive, then f is concave up. So all of those things I kind of connected. And likewise, if f is concave up, that means f double prime is positive, which also means f prime is increasing. So you can kind of go either way. If f prime is decreasing, so the slope of f prime is negative, well, the slope of f prime is f double prime. So f double prime is negative. And if f double prime is negative, that means f is concave down. If f prime has a relative maximum, then f double prime is, so let's just, if something has a relative maximum, then the slope is 0 or undefined and changes from, so f double prime, the slope of f prime changes from positive to negative. Okay, well, if f double prime changes from positive to negative, that means f has a point of inflection. So again, you should be able to get one of these and then kind of work backwards as well. If f has a point of inflection, then f prime has a relative max or a min. So if f prime has a relative minimum, then f double prime is 0 or undefined, because again, f double prime is the slope of f prime. If f prime has a relative minimum, then f double prime changes from negative to positive. And that means f has a point of inflection. All right, let's do this true-false quiz. And I'm going to try to draw examples when I can, or counterexamples. So if f prime equals 0, does that mean f has a max or a min? No, definitely not. And there's a couple of different things I can say. Okay, well, I can have a minimum, yes, if f prime is equal to 0. I could have a maximum, yes, if f prime equals 0. But what if your slope was 0 and there was not a max or a min? You can flatten out and not have a max or a min. So just because your slope is 0, that does not make it a max or a min. Another example would be what if I just had a horizontal line? The slope is 0 and no max or min. So just because the slope is 0, that does not mean you have a maximum or a minimum. If f prime equals 0, we call that a critical point. And a critical point is critical points are candidates for maxes and mins, but critical points are not actually maxes or mins necessarily. You have to remember that there is a change to have a max or a min. All right, if f prime changes from increasing to decreasing, does f have a point of inflection? So f prime, so if I graph f prime, and it changes from increasing to decreasing, is there a point of inflection? Yes. Now, why is that? Because if f prime changes from increasing to decreasing, that means f double prime changes signs. Remember, f double prime is the slope of f prime. And if f double prime changes sign, then yes, f has a point of inflection. So that is true. All right, if f double prime is greater than 0, f is concave up. That is true. So that's just a definition. F is concave up. F double prime is positive. If f double prime is positive, f prime is concave up. No. Double prime is the slope of f prime. Remember, f double prime is the slope of f prime. So if f double prime is positive, that means the slope of f prime is positive. If the slope of f prime is positive, f prime is increasing. So if f prime is increasing, but it is not concave up. If f prime is undefined and changes from negative to positive, then f has a minimum. So if f prime is undefined and changes from negative to positive, f has a minimum. That is true. If f prime is increasing, does that mean f is increasing? No, of course not. If f prime is increasing, so let's say this is the graph of f prime. Let's say f prime is increasing, but it's negative. Then f isn't increasing, it's actually decreasing. So just because f prime is increasing does not mean f is increasing. If f double prime is equal to 0 or undefined, f has a point of inflection. No, there has to be a change in concavity to have a point of inflection. There must be a change in concavity. So let me give you an example. x to the fourth looks like this. Now, f double prime, if you were to find f double prime, so this is f prime using the power rule is 4x cubed. F double prime is equal to 12x squared. F double prime, 12x squared, looks like this. So this is f, and this is f double prime. If f double prime does not change signs, there is no change in concavity on f. You'll notice that f is just concave up. F double prime is never negative. So there is no point of inflection. There has to be a change in concavity. So f, you'll notice, does not have a point of inflection. And f double prime does equal 0. So just because f double prime equals 0, that does not mean f has a point of inflection. Again, f, you can see in my picture, f does not have a point of inflection. It's just concave up the whole time. F double prime is equal to 0, but there is no change in sign. So there has to be a change in sign for f to have a point of inflection. Sorry, there has to be a change in sign on f double prime for f to have a point of inflection. All right, and if f prime is less than 0, does that mean f is decreasing? Yes, that is true. F prime is the slope of f. If the slope of f is negative, then f is decreasing.